Hello, I'm James Stanley. I'm one of the musicians on the plugin project, which is primarily focused on using music technology with young people in mental health settings. And I'm finding more and more people are interested in creating electronic music, using music technology, and specifically using synthesizers or learning more about synthesis, whether that is inside a piece of software, or whether that is with a physical synth or keyboard, piece of hardware that you have in front of you. However, there's lots of confusing things for people that want to pick it up the first time. Lots of dials and switches and stuff that makes absolutely no sense and is abbreviated in all sorts of weird ways. So it can be quite daunting to even get a sound out of one of these things sometimes. So I wanted to do a quick little walkthrough video to explain some of the most basic functions which you will find on every synthesizer, whether hardware or software, so that if you're in a situation where you pick one up, it will make a little bit more sense to you. And I will be using Arturia's emulation of the Prophet 5 for this little demonstration, just because it's laid out quite simply. So the first thing to draw your attention to, which we will find on every single synth ever created, is what's known as an oscillator. This might be abbreviated to OSC, but you'll be able to find it somewhere on the interface. And this is the way that the synthesizer is going to initially create sound. Every sound that we hear is simply a sound wave, whether that is a traditional instrument, an electronic instrument, our voice, whatever it might be. It's our ears picking up on a certain frequency pattern and then translating that into noise. So that's exactly what we can choose with the various oscillators. Now, electronic instruments give us various different shapes or waves that we can play with and hear. Those shapes are going to sound very different. They've all got different names. In mine here, I've just got two. So I've got this square wave and I've got this sharper wave. There's lots of different names for them. So we've got sine waves, a nice smooth curve. We've got sawtooth waves, square waves, many different options. There might be 8, 9, 10 or hundreds inside your piece of software. So experiment with them. This is going to be the basic starting point, the most simple version of your sound. Within the oscillator function, you will always then have a couple of other different options. One which is going to help you to tune that up or down. You might also see something called PW, which stands for pulse width. Once we know what that stands for, it makes sense what it does. As we move that dial, we can hear the sound getting thinner or thicker. We'll leave it somewhere in the middle for now. Most synths will tend to give you the option of combining multiple oscillators or sound sources together. So we can start to experiment with maybe a square wave and a sawtooth wave at the same time. There will then always be a mixer where you can turn up the volume between the two oscillators, oscillator A, oscillator B. Sometimes it'll be oscillator 1, oscillator 2. Don't get confused by that, it still means the same thing. For now though, I'll just stick with oscillator A, one sound source, so that we can hear everything else that is happening within inside this synth. Moving on the chain from the oscillator, we'll then find something else in every single synth. The filter is incredibly useful for carving away at your sound, and essentially what it does is filters out frequencies of sound that we don't want or emphasizes parts that we do. If we take the cutoff as the most important part of this filter, if I hold down a key and then drag that filter down and then take it back up, you can hear there that it's taken away all of the higher frequencies. So by the time we're at the bottom end of the dial, we've just got these lower frequencies left. Now, depending on the sound that you're making, you might want one or the other. The next thing that you'll notice is this reso stands for resonance, and it's maybe easier for you to see what that does on an equalizer. This equalizer here, where we can see the low end of the sound spectrum and the high end of the sound spectrum. Essentially what we're doing with a filter is gradually taking away some of that sound. What the resonance feature does is boosts the very highest frequency that is still left. So if I push this up, you can see that this little section now, the very highest part, as I play, is going to move down, and you'll get this sort of filter sweep sound where you can really hear that frequency that it's taken away. So if we do that with inside this plugin, if I turn the resonance right up, you'll hear the difference. And you can get these really interesting kind of synthetic, very electronic sort of sounding sounds. So that's a filter. For now, we'll just leave it so that it's turned off all of the time, so we can hear all of the sounds coming through for the next section, which is the amplifier. Now, this is the bit that can start looking really confusing, and also it might be the place to look if you're trying to make a sound and nothing is coming out at all. We've got these 4 different dials here, so attack, decay, sustain, and release. Oftentimes, they will just be A, D, S, and R. If you don't know what they stand for, it gets quite complicated. So attack, decay, sustain, and release. And it's going to dictate the level of the sound, so the volume of this sound. So as I press the key now, we can hear that it's literally the same all the way through. As soon as I hit the key, it's at its loudest volume, and it stays that way until I let go of the key. If I was to turn this sustain one down, notice I'm pressing the key here, but there's absolutely no sound. It's just giving you this little click, which can be quite useful if you're creating kick drums or other short sort of percussive sounds. But that might be a reason why you're not getting any noise from your synthesizer. So one of the first things to check is, let's go to the amplifier. Let's turn the sustain right the way up, because it's going to mean that it can hold that note for a little bit longer. We can start to change these and notice how it is impacting the sound. So if I was to turn the attack all the way up and hit the key now, it's now going to take a long time to get up to that initial point. And we can dial this in, so we get these nice little swells. Attack is probably the most useful one for many of the sounds that you're creating. But then the opposite end of the spectrum is also useful. So at the moment, no matter how long it takes for that sound to come in, it's going to stop as soon as we release the key. The release button, or the release knob, or however it is on your synthesizer, is going to mean that that note lasts for longer than you hold the key down for. So I'm going to hold it, I'm going to let go, and we can hear that it just gradually dies away now. Again, dial that in to where it feels sort of natural and organic. Can be really nice for if you're wanting sounds to last for longer whilst you're moving and changing chords. And then your 2 in the middle, so the sustain is where that note is going to be held once it's reached the highest point and you've still got your finger on the key. So if I was to turn that right down, the attack is going to go all the way up, but then it's going to drop down to this slightly lower level of volume and then stay at that volume instead. They're quite good for sort of pumping sounds that you want to initially have quite a big hit and then to drop down and get lower. And then the decay is how long it takes from when the sound has reached its loudest point here to then what it's going to drop down for the sustain value. How long is it going to take to get there? So at the moment, it's instant. It goes up. As soon as it's got to the top, it drops back down to the sustain level. If I turn that decay up, it's just going to take a little bit longer to get there. So that is the amplifier section. So try and keep this attack, decay, sustain, release, language, ADSR in your heads, because it comes up quite a lot in synthesis in other places than the amplifier. As an example, if we head over to the filter again, you'll notice ADSR, attack, decay, sustain, release, exactly the same setup, and they are going to work exactly the same as what we've just done over here, same function, but instead of applying themselves to the volume of the overall sound, it's going to apply itself to the filter. So remember that cutoff that we had before that was bringing frequencies in and out? We can now modulate or automate that with this envelope section: attack, decay, sustain, release. If we were to turn the attack up on the filter and then bring this cutoff down, notice now that gradually we're bringing this sound in, so we've got a bit of a swell, not in volume, the volume stays the same, but the filter is coming in at that kind of more gradual pace. You can get an electronic instrument, something which initially was just this one very, very basic sound, to sound a lot more organic and a lot more expressive, because it's changing and evolving over time, coming in at different speeds, etc. And that is why this ADSR, sometimes known as an envelope, is really, really useful, because we can apply it to various different places. Here, it's the filter. Here, it's the amplifier. On your synth, you might see the same thing, ADSR, but in a different place. So learning what that does is really, really useful. The last thing is the LFO, Low Frequency Oscillator. This stands for, so you might see it written out in full, but more often than not you will see LFO. We've already spoken about oscillators being waves inside the oscillator. That wave created a sound. Here we've still got waves, and we've got actually some of the same patterns here. So we've got sawtooth waves, square waves. Again, there could be any number of options. But it's not going to create a sound. Instead, it's going to play that wave and apply it as a modulator to a sound of your choosing. We can, at the bottom, apply it to various different things. So we can apply it to frequencies, we can apply it to the pulse width. But we've spoken a lot about the filter, so we'll apply it here. This time, as we turn the cutoff down, it's not doing this sweep once and then staying in the same place as it did with the envelope, but instead it's doing it over and over again in this pattern or this shape. So it's reaching the peak, it's going down. It's reaching the peak and going down. If we change it to a square wave, we'll hear that rather than having a little sweep and movement, it just switches between one cutoff and the other. Again, really useful for creating sounds that develop and evolve over time. You can always find a rate option. So if we hear that, we could just gradually speed it up, slow it down. Now remember, once you understand the idea of an LFO, so a low frequency oscillator, or a shape which is then going to modulate a part of the sound, you can use it in so many creative ways and in multiple places. So oftentimes you can link that LFO not just to the filter, but to pitches and to volume and to effects and to oscillator shapes and all sorts of other places. That means that you can start to create really, really interesting sounds. And that's probably enough. Like I say, every synth is going to have more features than that. Just experiment, play around with the things that I've not explained here. That is the beauty of electronic music and synthesizers, is just the sort of the unknown of what something might do to a sound, and those unexpected accidents sometimes can be the most creative and the most interesting things. But from that video, you'll be able to start making sound with whatever synth you've got access to. You'll understand what an oscillator is, how you can potentially combine multiple oscillators together, how you can then affect that oscillator with the filter using cutoff and resonance, and then a little look at envelopes, the ADSR, attack, decay, sustain and release, which impacts sound in different ways depending on where it is, so to do with the volume or to do with the filter. And then we've had a look at low frequency oscillators, which will help to continuously modulate a sound over a period of time.